Today I will discuss hybrid model analysis of common emitter transistor. In the last lecture, I have discussed about the H parameter model of a bipolar junction transistor. Specifically, I have shown there how to replace a physical transistor by the H parameter model. There I mentioned that the H parameter model is essential for the analysis of small amplitude low frequency amplifier. Low frequency means less than 1 gigahertz. Okay. In the H parameter model, a BJT is represented by two equations. This is the input voltage to the transistor equal to HI II plus HR V0. II is the input current and V0 is the output voltage, and output current is equal to HF into II plus HO into V0. Here HI means input resistance of the transistor, HR means reverse voltage gain of the transistor, HF means forward current gain, and HO means output admittance of the transistor. Now, this equation is specifically the Kirchhoff's voltage law. The Kirchhoff's voltage rule, and this equation specifically the Kirchhoff's current rule, because this term is current, this term is also current because HF is dimensionless and HO means current by voltage cancel out, this is current. Therefore, it is the conservation of current. And here it is the conservation of voltage. That's why it is KVL and the KCL. This is the H parameter model. H parameter model diagrammatically is represented by this one. Okay, is this one. Now here these are two general equations, because here you see I have not mentioned any configuration. Configuration means the transistor can be used in any one of three configurations. One is the common emitter configuration, common base configuration, common collector configuration. Okay, because transistor is a two-port network, therefore one terminal, it has three terminal, emitter, base, collector. One terminal is used in common. If emitter is common, then it is common emitter. If base is common, common base. If collector is common, common collector. Therefore, for common emitter, HI becomes HIE, meaning HI is the input resistance. Therefore, input resistance of the transistor in common emitter mode, HIE. HR means HRE, HF means HFE, HO means HOE. Therefore, reverse voltage gain with emitter common, forward current gain with emitter common, output admittance with emitter common. This is the common emitter. For common base, Hi is equal to HIB. HR is HRB. HF means HFB. HO means HOB. Here, input resistance of the transistor with base common, reverse voltage gain with base common, forward current gain with base common, output admittance with base common. Similarly, for common collector, HIC, HRC, HFC and HOC. Therefore, now in our discussion as per the syllabus, I restrict my discussion in common emitter mode. Now, in common emitter mode, emitter is common. Here it is the input and here it is the output. Now, base is the input current. Therefore, II is the IB and collector current is the output current. I am giving I0 and VI is the input voltage, input voltage across the transistor, and Vout is the output voltage across the transistor. Therefore, this is IB and HIE means HIE, HAP, HRE, HOE. Therefore, the diagrammatically these two equations can be written as this is HIE, RE, this is IB, this is IB, HAP and HOE and this is U. Therefore, this is the H parameter model of the transistor in common emitter mode. Here the emitter is grounded, therefore keep it ground. Okay. Now, I want to analyze. Now, today's discussion is the analysis of common emitter bipolar junction transistor, common emitter bipolar junction transistor replaced by H parameter model. This is your model. Now, to analyze this circuit, I have to complete the output and the input. Therefore, to complete the output, I am connecting the output with a load. And there is a input signal on the input side. Okay. Analysis means want to calculate. Analysis means we want to calculate the input impedance or resistance, whatever you can say, impedance, output impedance, voltage current gain, and voltage gain of the transistor with load from the H parameter model. Okay, this is called hybrid model analysis of the transistor. That's why I given the title hybrid model analysis of the transistor. Okay, what the analysis? Analysis means I want to calculate input impedance, output impedance, current gain, voltage gain of the transistor. Okay, from this circuit. Current gain. First current gain. Denoted by AI. Now see, here from the circuit you see I0 and IL are opposite to each other. It is going in this direction, it is going in this direction. Okay, therefore I0 and IL equal to minus I0. Load current, output current. Okay, and second is V0. This is your V0. This is your V0. Therefore, V0 is equal to IL into RL. Now, IL is equal to minus I0. Therefore, minus I0 into RL. And here, I means IB, base current. Okay? This is the base current and this is the collector current. I want to find the current gain of the amplifier. Hybrid model is VI equal to HIE into IB plus RE into V collector or V0, and then I0 is equal to HFE into IB plus HOE into V0. Okay, this is the now from this equation. Okay, from equation number 1 equation number 2. Okay, therefore from equation 2 because I want current gain definition ki na current gain definition hochi AI equal to IL by IB. This is the definition of the current gain. Okay, output current by input current. Okay, that is the current gain. Now, what is IL? IL is equal to minus I0. This is equal to minus I0 by IB. Now, from equation 2, I0 is equal to this one. Yes, sir. Okay. Therefore, using equation 2, we get AI equal to minus HFE into IB plus HOE into V0 by IB. Okay, this is equal to minus HAP into IB by IB minus HOE into V naught by IB. Okay, therefore this one. Next is V naught is equal to minus I naught into RL. Therefore this is equal to IB cancel out, minus HAP minus HOE into V naught is equal to minus I naught into RL by IB. This is equal to minus HAP, अच्छा, it into minus sign दिला. Okay. Now minus I naught by IB होगी AI. Therefore minus AP minus HOE into AI into RL. Here?
Yes.
Here and here. Take on one side. Therefore AI plus HOE into AI into RL equal to minus HAP. Take AI common. 1 plus HOE into RL is equal to minus HAP. Hence AI equal to minus HAP by 1 plus HOE into RL. This is the expression of current gain of the transistor with load. Okay, this is the current gain. Now next, here you see negative side. Here you see negative. What is the meaning of the negative sign? Negative signs mean 180-degree phase shift. Okay, 180-degree phase shift means if the input is this one, okay, this is the VI. If input is this, then the output will be 180-degree phase change. This one amplified version. This is the very small signal. Input is very small signal, but output will be large, but 180-degree phase change. When it is positive, it is negative. When it is negative, it is positive. That's why minus sign comes. Okay, because this is the current gain. Output and input has the 180-degree out of phase. That's why this negative sign. Next is input resistance. Next is now input impedance. Input impedance of the transistor with load. Okay, with load. Now definition again. Now ZI, input impedance means input voltage by input current. Input current is IB, input voltage is VI. Okay, therefore VI by IB. Right?
Yes.
VI by I. Now, from question 1, we have VI equal to HIE into IB plus HRE into V naught by IB. Okay?
Yes, sir.
Now, this can be written as, now V naught is equal to minus I naught into RL. Then HIE plus HRE into minus I naught into RL by IB. Okay?
Yes.
This is equal to HIE plus HRE into minus I naught by IB into RL. Now, minus I naught by IB is the current gain AI. This is equal to HIE plus HRE into AI into RL. Now, we know current gain AI equal to minus HAP by 1 plus HOE into RL. Put this in here. We get ZI equal to HIE plus HRE into minus HAP by 1 plus HOE into RL into RL. Okay, well, take the sum rate. This is equal to HIE into 1 plus HOE into RL plus HRE minus HAP into RL by
1 plus
1 plus HOE into RL. Fine. This is equal to HIE plus HIE HOE. Okay?
Yes, sir.
Take RL common from these two terms. HIE minus HOE minus HRE into HAP into RL by 1 plus HOE into RL.
Yes.
Right? Now, take this term delta H. No, don't take the negative side. Take this term as delta H. Okay? Then we can write ZI equal to HIE plus delta H into RL by 1 plus HOE into RL, where delta H equal to HIE minus into HOE minus HRE into HAP. Okay? Now, it is a constant. Take the dimension. HIE has the dimension O. HOE has the dimension 1 by O. Minus HRE dimensionless, HAP dimensionless. Therefore, this is a dimensionless quantity. Okay? This is a dimensionless quantity. Therefore, take, now I am telling it is impedance. Impedance means ohm. You see, it is ohm. This is dimensionless. This is ohm. Therefore, numerator is ohm. And denominator you see 1 plus HOE means 1 by resistance. Resistance will calculate. This is dimensionless. Therefore, this expression is the resistance. Okay? Next, voltage gain of from the hybrid model with transistor load. Okay? Voltage gain. It is defined as AV equal to VL by VL means VO. VO is taken across this.
Yes, sir.
That is the VL. VO by input voltage VI. This is the voltage gain. Now VO means IL into RL by VI.
Mine.
Next, this VI, I know ZI.
Yes, sir.
ZI I know, and input current I know. Therefore, VI is equal to ZI into IB. Okay. Then AV is equal to IL into RL by ZI into IB. This is equal to IL means minus I naught by IB into RL by ZI. Now minus I naught by IB is AI.
Yeah, yes, sir.
Therefore, this is equal to AI into RL by ZI. Put the AI and ZI both. I have AI is equal to minus HAP by 1 plus HOE into RL, and ZI is equal to HIE plus delta H into RL by 1 plus HOE into RL. Put AI and ZI here. Then we get AV equal to AI means minus HAP by 1 plus HOE into RL by ZI ZI means HIE plus delta H into RL by 1 plus HOE into RL. Now you see here 1 plus HOE into RL, here also 1 plus HOE into RL. That they will cancel. Therefore, this is equal to minus HAP into RL by again negative sign.
Yes, sir.
Negative sign why? Because input signal and output signal. AV means output by input.
Yes, sir.
Therefore, they are 180 degree out of phase. That's why this negative sign comes. Okay? And now this is dimensionless quantity and this is ohm. And here it is also ohm. But it is dimensionless quantity. It is ohm, it is ohm. Therefore, ohm by ohm,
Then, sir.
dimensionless. Here, V naught is volt, Vi is volt. Therefore, dimensionless. Therefore, AV is dimensionless.
Yes.
Okay? That is the gain. Fine? Next, output impedance. From the hybrid model with load. Okay? Now, to find the output impedance, we have to make the input source 0. This is the tricks. Input source 0. That means what is the meaning? Meaning is if the input is voltage signal, then make it short circuit. And if input is current signal, then make it open circuit. Open circuit করতে না ইনফাইনাইট রেজিস্ট্যান্স কারেন্ট আর ফ্লো করব না and voltage signal short circuit, if there is short circuit no voltage drop. Okay, therefore input source has to be 0. Therefore here if input, here it is IB. Now if input current is 0, input source is 0, therefore input current is 0, then this is 0. I have to calculate the output impedance. Therefore output impedance is nothing but the parallel combination of this.
Yes, sir.
Okay, therefore output impedance, if input signal is dropped, then IB equal to 0. Okay, IB is equal to 0 implies HAP into IB equal to 0. Then from the hybrid circuit, then from the hybrid model circuit, we have the output impedance ZO is equal to parallel combination of RL and 1 by HV. This is equal to 1 by HOE into RL by 1 by HOE plus RL. This is equal to RL by 1 plus HOE into RL. Now you see, HOE into RL is dimensionless quantity. Therefore denominator is dimensionless. It is the ohm. That's why it is the output impedance. Okay. Hence, everything you done. Next is the power gain. Definition की ना AP is equal to voltage gain into current gain. Right?
Yes, sir.
Now, what is the voltage gain expression? Voltage gain expression is minus HAP
RL
into RL by HIE plus del H into RL into AI is equal to minus HAP by 1 plus HOE into RL. Right? Therefore, this negative sign will cancel out. Therefore, this is equal to HAP square into RL by HIE plus delta H into RL into 1 plus HOE into RL. This is the, now take the dimension. Voltage gain into current. Voltage gain is a dimensionless quantity. Current gain is a dimensionless quantity. Therefore, this is dimensionless. Now come here. It is HAP is dimensionless. This is RL. Now this is resistance. It is dimensionless. Therefore, this is resistance. Here it is dimensionless because HOE is the 1 by resistance. Resistance cancel out. This is dimensionless. Therefore, this is resistance. This is resistance. They will cancel out. Therefore, this is dimensionless. Fine. From the given amplifier circuit, I can do DC analysis and AC analysis. For DC analysis, no need of hybrid model. Now, from this circuit, amplifier circuit, how you can draw the DC circuit? Now, to draw the DC circuit, make, now this is the capacitor is open for the DC. Therefore, this is 0. This is 0, this is 0, this is 0. Therefore, C1 equal to C2 equal to C3 is equal to 0. Therefore, if it is open, then these are not connected to transistor. Okay? Here it is open. It is short circuit. Open. Open means this one. Okay? And here it is open. Therefore, load is disconnected. Therefore, this is your DC circuit. Here no AC. You see, signal is disconnected. It is voltage, and here load is also disconnected because capacitor is open. Therefore, to draw the DC circuit, you have to make C1 equal to C2 equal to C3 is equal to 0. Okay. Now you see, from the output here we get VCC equal to, here it is IC into RC plus VCE. Okay, right? Therefore, VCE is equal to VCC minus IC into RC. Now, if you connect the signal, then the signal looks like this. Signal looks like this. Therefore, when signal is increasing, then IB is increasing. If IB increase, you know IC will increase.
Yes, sir.
Because beta times IB. Okay? Therefore, IC is large, VCC is small. Therefore, this is negative.
Yes, sir.
Therefore, if IB is positive, then IC is positive, but IC is large. Therefore, this term is more than this. Therefore, VC is negative. Therefore, output will be negative. Again, when IB is negative, then IC will be negative. Therefore, negative is positive. Therefore, VC is positive. Therefore, this one. Hence, you see, here is the 180 degree out of phase. Okay, that's why in the hybrid model analysis of the transistor, we got the AI and AV negative because the input and output are 180 degree out of phase.
Yes, sir.
For the AC analysis, if you want to draw the equivalent hybrid model for the AC analysis, you need the hybrid model, okay, of the transistor. Therefore, if you want to draw the hybrid model of the given amplifier circuit, then how can I do? For AC circuit, make For AC, C1, C2, C3 are short circuited. Okay? Therefore, C1, C2 and C3 are short circuited. Okay? Short circuit করিও তাহলে কি হলো? Therefore, this is short and this is short. Okay? Next, make the DC source grounded. Make DC source grounded because any DC source involves capacitor. Through that capacitor, it will be AC will be grounded. Therefore, make DC grounded. Make DC grounded. Now, from the amplifier circuit, draw the hybrid model circuit of the given amplifier, not the transistor, of the amplifier. Draw the hybrid model circuit of the given amplifier. Okay? Now, therefore, draw. Here it is the ground. First, here it is the transistor. Transistor means it is the transistor. Okay? Transistor. Fine? Base, emitter, collector. Okay? Now, you see, emitter, since it is short circuited, emitter is directly grounded for the AC.
Yes, sir.
Therefore, since it is grounded, therefore there is no RE. Okay? RE. Therefore, this is directly grounded. Next, here you see it is grounded. Therefore, R1 is ground between base and the ground. R1 is between base and the ground. R2 is also between base and the ground. Okay? Therefore, R2 is also between base and the ground. Next, this is your RS and this is VS. Now, RS is between base and the through signal ground. Therefore, this is RS, this is VS. Side. RC is between collector and the ground. RC is between collector and ground. Okay? Next, RL between collector and the ground. Therefore, this is also collector and the ground. And here it is the V0 and here it is IB or II and here is the emitter. Fine, I am not complicated because I have to replace the transistor by the hybrid model. Okay? I have to replace the transistor by hybrid model. Now, replace. This is your HIE this is your HRE into V naught, and here this is your 1 by HOE and this is your HAP into IB, right? Now this is called hybrid model CE amplifier circuit. Here, this is your HIE and this is very difficult. Now the analysis means I want to calculate the input impedance, output impedance, current gain, voltage gain, power gain. Now with the hybrid model, it is very difficult to calculate these one. Okay, that's why we use a simplified model. Now the condition is if HOE into RL is less than 0.1, then we can use a simplified model of the simplified hybrid model of the transistor. We can simplify. If this condition is satisfied, we can simplify. Because from the hybrid model circuit, it is very difficult to analyze the amplifier. That's why we simplify the hybrid model. That simplified model is called approximate hybrid model. Approximate hybrid model. That simplified model is called approximate hybrid model. Now, how can we simplify? Let me see. Now, we know for common emitter transistor, HR and HRE and OE are very, very less compared to the other. So make this HRE is very negligible, therefore make it 0. HOE 1 by HOE. Now HOE is very small, therefore this is very large, means infinite. This is infinite. Infinite means
Short.
open. Infinite. Infinite means open.
Yes, sir.
HOE of the very small of the 0, therefore 1 by HOE is infinite, therefore this is open. And HRE is approximately 0, therefore forget about this. Therefore this is the approximate hybrid model of the amplifier. From this circuit, we will analyze the AC behavior of the amplifier. Therefore, we will use this circuit to analyze the amplifier, complementary amplifier using approximate hybrid model, not the hybrid model, because hybrid model analysis is extremely difficult, complicated. Therefore, we are making approximation, simplifying we are making. Now, you see here R1 and R2 each parallel. Take RB is equal to R1 parallel R2. That means R1 R2 by R1 plus R2. Again, RL and RC are parallel. Therefore, take RCL is equal to RC parallel RL. This is equal to RC into RL by RC plus RL. Okay? Therefore, our circuit becomes our hybrid model circuit of the amplifier becomes, this is your RB and this is your HIE. Okay, and here this is your RCL and this is your RCL. It is the V naught. Fine. This is your IB and here it is RS. Everything right.